This video will be going over the April 5th assignment over composite volume and surface area mixed exercise A. We're going to start off with question number 1. Number 1 says a can of peas is 3.5 inches tall and has a diameter of 1.5 inches. How much paper is needed to make the label for the can? It just wants us to find the lateral surface area, okay? We're talking about a can of peas. It's usually in a cylindrical can. Okay, so here's our cylinder. Our lateral surface area formula for a cylinder is S is equal to 2 times pi times radius times height. So we need to know the radius. And we need to know the height. Okay, so we know the radius goes from the center of the cylinder to the edge of the circle. Okay. We know when we're talking about cylinders, our shape of the bases are circles. Okay, we have one on the bottom, one on top. Okay. All right. So if our diameter is 1.5 inches long, that means if the whole thing is 1.5 inches, half of it is going to be 0.75. Okay. So our radius is equal to 0.75 inches. Okay. Our height, it says the can is 3.5 inches tall. Okay, so we'll drop down 3.5 times pi times 2. We just drop everything down. All right, so we have 2 times pi times 0.75 times 3.5. All right, so we're going to plug this all in our calculator. We have 2 times pi times 0.75 times 3.5. We get 16 we'll round up to 5/10. So we have 16/5 inches, and we found the lateral surface area, so it's squared, which is answer choice B. All right, we're going to go down to question number 2. Number 2 says Miss Ringo has a cylindrical aquarium with a height of 10 inches, so our H is 10, and a diameter of 6. All right, so if our diameter is from side to side of the circle, if that is 6, half of it is 3. Okay. All right, so radius is 3. The height of the water in the aquarium is 7 inches. Okay, so that means we're going to have 2 cylinders. We're going to have the one that's the big aquarium. Here's our big aquarium. All right. Then here inside of it is just the water level. So we have 2 cylinders. Okay. We have a big one and we have a small one. Height of the water in the aquarium is 7 inches. So that's another height. Approximately how much volume of water is in the aquarium. So we're not really worried about the purple cylinder. We just want the blue cylinder. Okay. So we can ignore the height of 10 inches because that's the aquarium. We just want to know the water height, which is 7. And we said the radius is 3. Okay, so now we have our little cylinder. All right, so the volume formula for a cylinder is V is equal to big B times H, okay? But we have to replace big B with the area formula of the base. We know the shape of the base is a circle. The area formula is pi radius squared. So if we rewrite this volume formula, we have pi radius squared in parentheses times the height, okay? So our R is 3 and our height is 7, okay? We just drop down everything else. All right, let's go plug this in the calculator. So we have pi times 3 squared. And we get this, and we multiply it by the height of 7. We get 197.9. Okay, 197.9 inches cubed. It's cubed because we found the volume. Okay, we can see answer choice A is correct. If we round this up, we'll get 198, which is the exact answer for number 2. All right, we're going to skip down to question number 5. right, question 5 says, find the volume of the soccer ball if the diameter is 12. Okay, so we want the volume of the soccer ball and the diameter is 12. So if it goes from side to side is 12, we know half of 12 is 6. So 6 is our radius, okay? Our volume formula for a sphere is 4/3 times pi times radius cubed. Right? We know our radius is 6, so all we have to do is plug in our radius into our equation. So we have volume is equal to, we drop down the 4/3 times we drop down the pi. We replace r with the number 6, and we drop down the power of 3. We plug it into our calculator, control divide. We have 4/3 times pi times 6 to the power of 3. And we get 904, and if we round out, 8 tenths. Okay, 904, 8 tenths centimeters, and we found the volume, so cubed. Okay, which we can see is answer choice B for number 5. All right, we're not going to do number 6, but just know number 6 is the same steps as number 5. Just know our radius is a little different here. But for number 6, it says we want to find the volume if half the air is let out. So if we wanted to find just half of the air in question number 5, we would take this answer, and at the end we would divide it by 2. Okay, so when you go over number 6, that's what you're doing. You're taking your final answer, you're dividing by 2, because we only want half of this shape. We don't want the bottom half of this. Okay. All right, we're going to skip down to question number 8 now. Number 8 says, Frederick wrapped the outside of a gift like a rectangular prism. The box is 2 tenths feet long, 3 8 feet wide, and 2 7 feet high. What is the approximate total surface area? Okay, so here's our gift box. We want to find the total surface area of a prism. The surface area formula is big P times H plus 2 times big B. Remember, big P represents the perimeter of the base, and big B is the area of the base, okay? So if we're on the side, I'm going to write the letters that we need to find to plug into our formula, okay? Let's start off with the 3D height. If we know our base is down here, okay, we know from the bottom base to the top base, we're going up 2.7 feet, okay? So we have our height. Now let's find the perimeter. Here's our base down here. We have 5.2, 5.2, 3.8, 3.8. So I just redrew just the bottom part of this box, okay? Just the bottom part, all the way over here, okay? P is the perimeter, so we're going to take all these numbers and add them all up. So we have 5.2 plus 5.2 plus 3.8 plus 3.8. We get 18. So the perimeter is 18. Okay, and the area of the base. The area of a rectangle is length times the width. Okay, so we're doing 5.2 times 3.8. So 5.2 times 3.8 is equal to 19.76 Okay, we have all of our numbers for the letters we need to plug in, so we'll go ahead and plug all those into our formula. So we have S is equal to 18 for big P. We have 2.7 for H, so times 2.7. Plus, we drop down this 2 times our big B, which is 19.76. Okay? We'll type this all into the calculator. 18 times 2.7 plus 2 times, what was that second number? 19.6 or 76. We get 88 1200. This is feet. We found the surface area, keyword area, so our answer is squared. We see that answer choice B is the closest answer, so B is correct for number 8. Last question we're going to do is number 9. Number 9 says the maximum volume the sand prism box can hold is 40 cubic feet. So it already gave us our volume, so this is our volume. What is the height? We want to find the height of the sandbox in feet. Okay, So the volume formula for a prism is big B times H, okay? Now, big B, we always change it with the area formula for the base, okay? We know the base is in the shape of a square. It's a 4 by 4 square. So this side's 4, this side back here is 4, and then this side is 4. Okay, the area formula for a square is length times width. So now we have volume is equal to length times width times the height. All right. Now, when we read the question, we see that it already gave us our volume of 40. So let's go ahead and plug that in. Okay, so we have 40 for our volume. Okay. We can go ahead and find our area of the base, which is length times width, which we already said is 4 and 4. So 4 times 4 is equal to 16 times the height. Okay. All right. We don't know the height. So now we need to find the height. To get the height all by itself over here, we need to get rid of the 16 somehow. And by getting rid of it, what we need to do is we need to divide this side by 16 and divide this side by 16. Okay. So 40 divided by 16 is equal to 2.5 feet. Okay, so height is equal to 2.5 feet. Okay, so we can see that question, our answer choice C is the correct answer. That's going to wrap up the April, what was this, 5th assignment over composite volume and surface area mix exercise A. If you need to do the redo assignment, go ahead and click on that.